6.3 is going to talk about compound inequalities. In 6.1, we studied 4 types of simple inequalities, and in this lesson, you will study compound inequalities. A compound inequality consists of 2 inequalities connected by and or by or. So if we're going to write an inequality that represents a set of numbers and graph the inequality, first of all real numbers that are greater than 0 and less or equal to 4. Our solution would be, as I have down here on the graph, if it's an and, the graphing will connect 2 points. It needs to be greater than, so it is an open point at 0, but it also needs to be, because of the and, less than or equal to, so we're going to have a solid point on 4. Now the solution set can be anything between it because it is an and, all the numbers that are between there. Now the next solution is going to talk about real numbers that are less than -1 or greater than 2. So if you're going to have the or in the sentence, you're going to notice that the arrows or the shaded area are going to go 2 separate ways. So the real numbers that are less than -1, again, it's just the less than, so it is an open point and it is shaded to the left. Because it is an or statement, we have the other part of the equation, greater than 2, again just greater than, so it's an open point, but this time it's shaded in the opposite direction. So if you have an or statement, the in-between is not connected. They're going to go in opposite directions. Whoops, too many points there. So how do we write these compound inequalities if we're talking about a real life situation? So we're going to look at Mount Rainier. And the first thing they're going to ask us is they're going to write an inequality that describes the elevation of the regions of Mount Rainier. So first of all, if I'm going to talk about the timber region, the timber region starts out at 2,000 feet and goes to 6,000 feet. Now, it can be at 2,000 feet to be part of the timber region. So I'm going to go ahead and I'm going to write 2,000. The area we're talking about is going to be greater than 2,000 or equal to it. But once you get to 6,000, 6,000 is the cutoff to start the alpine region. So I'm going to say this then has to be less than 6,000. This is an and situation. The timber region is 2,000 feet or more, and it has to be less than 6,000. So you're going to notice that my variable is in between and that my inequality symbols are both going in the same direction. Now if I'm going to do the alpine meadow region that happens to be below 7,500 feet, it's going to be the same type. We're going to start at, if it ended up being 6,000, it gets included, so that's a less than, I'm sorry, the x is going to be greater than or equal to 6,000, but it's going, the cutoff for that one is going to be 7,500 feet. And our last one then is the glacier region, and we're going to do the same type, and we're going to have 7,500 feet. It's going to be greater than or equal to that. But this time, because the Mount Rainier ends at 14,410 feet, it's going to have to be less than or equal to the maximum height there, 14,410. But again, all of these regions happen between 2, so they are and statements. Things to notice on the and statements, your variable is going to be in the middle. When you go to shade this, it will connect the 2 points, and all of the inequality symbols are going in the same direction. Moving on to example 3. This time we have the inequality with and. So we're going to go ahead and solve this. And to solve this, we need to remember the rule of balanced equations. So in order to get our variable by itself, we're going to need to add 8. Now this is as if we're doing two different equations. So we need to add 8 to each one of the parts of this equation. Subtracting. So I'm going to add 8 to the middle equation and then to both of the equations on either side. So negative 2 plus 8 is going to give me negative 6. My 3x minus 8 plus 6 is going to give me, or plus 8 is going to give me a 3x. And then my 10 plus 8 is going to give me 18. Now I did not need to reverse any symbols because I am only adding and subtracting at this point. Now, staying with the same rule of balanced equations, I'm going to divide by 3 to solve for my single variable, but that means I need to divide all parts by 3. I'm dividing by a positive 3, so I do not have to worry about reversing any symbols. So I would get negative 2 is less than or equal to my single variable x, which is less than or equal to a 6, sorry. So if you see, this is an and statement. So we're going to have connecting between the points. We're going to have our negative 2 as a solid point. Our positive 6 is a solid point because we have less than and greater than and equal to together. And then we're going to shade in between. Now, if you get it all confused, remember you can take, if you need to do a double check, and as we get going into more complex ones, this may be true, we can take that part of the equation there and we can reverse it so that it matches our graphing if the variable comes first. So when the variable's coming first, I want it to be pointing at negative 2, if you want to use that technical language. So looking at the negative 2 there, and so then you can see, yes, I'm going to shade to the right of negative 2. And then the other equation is already variable first. Moving on to example 4, this time we need to deal with the ors. And remember, when we deal with or, we're going to have a graph that is going into two different directions. So when we have an or, we actually have two different equations as well. So we have two simple equations here. We're going to subtract 1 from both sides. So I'm going to get 3x is less than 3. Divide by 3 on both. And I'm going to get x is less than 1. Now it's an or situation, so I'm going to solve my other equation. 2x minus 5 is going to be greater than 7. I want to add 5 to both sides. I'm going to get 2x is greater than 12. Divide by 2 to solve for my single, and I'm going to get x is greater than 6. Again, I did not have to apply any negative flipping, reversing the signs. Everything I did was dividing or multiplying by a positive number. And when we have that or situation, we have the graph that goes in two separate directions. Moving on to example 5, this time we're going to have follow the same rules we have been. However, we're going to be dealing with some multiplying or dividing by negatives. So there's going to be some reversing of signs. So be careful with this. It gets a little bit more confusing. So first of all, same rules. Let's get our our constant terms together. So if I want to get rid of a negative 2, I'm going to add 2 to each part. So now I have negative 2 plus 2 is 0. Only doing addition right now, so I don't need to worry about any other reversing of the signs. Now, the problem here is I have a negative x, so I need to multiply each part by a negative 1. Because I'm multiplying by a -1, that means I'm going to reverse my symbols. So now I have 0 times -1 is still going to be 0. Reverse that sign though. Negative x times -1 is going to give me x. And 3 times a -1 is going to give me -3. Now the problem with this is that our final sentence does not come in the order that it appears on a number line. So it is an and statement, so we can think about that. You can go ahead and change things into two separate ones if that helps you, but we need x to be greater than -3, so I have the open point at -3 shaded to the right, and then here is the other equation that is written kind of backwards. We have 0 is greater than x, or x is less than 0. So that is also an open point, and because it's an and statement, you see that they are shaded in between. Now, in example 6 is a little bit different. We have real life problems here. And we have, this one might be a good way to begin this problem, is to draw a diagram with a school at the center of the circle. Because we hear that Bill's home is somewhere on the circle with a radius of 3 miles and center at the school. Mary's home is somewhere on the circle with a radius of 2 miles and center at the school. So because we're dealing with the circles, it might be a little bit easier to draw that diagram. So if we go to write this statement, we're going to say if both homes are on the same line going toward the school, the distance is 1 mile. We can also tell if both homes are on the same line but in opposite directions, from the school, the distance is 5 miles. So the values of D can be described by the inequality that they're either going to be at equal to 1 or greater, and they could also be equal to 5 or less than. That's the maximum. So that is an and statement, including both of those inequalities. So if they were in a perfect line, those would be the two choices, and they could be anywhere in between there. So we have figured out the minimum and the maximum for that inequality statement. And that concludes 6.3.